At the offset living areas at the sides of the home, similar problems to those at the chimney area occurred, as evidenced by deterioration of the plywood sheathing and siding. In the bath area, these problems were also easily identified. They were incorrect roof flashing, improperly installed roof water diverters, improperly installed horizontal trim, vertical trim not caulked, extensive window leakage due to no flashing or caulking on the glass block window at all perimeters of the window, and lack of a bottom trim flashing to move water out and away from the interior structure. These deficiencies allowed water intrusion behind the siding, which resulted in rotted plywood sheathing, rotted structural framing, rotted horizontal and vertical wood trim, damage to structural framing components of the window offset, and minor hardboard siding deterioration. The hardboard siding itself performed better in these water intrusion conditions than any of the structural wood components. This is the result of improved moisture resistance built into the siding product during the manufacturing process. Also in the living area offset, similar problems existed. Namely, these were water leaking behind horizontal and vertical trim, water leaking at the window frame, and water leaking behind the horizontal trim because of short or improper flashing. Again, these deficiencies resulted in rotted trim and sheathing, water saturated and rotted wood framing members, mold, and wood decay. At the brick line of the home, water leakage behind the horizontal and vertical trim resulted in structural component damage. Porch area deterioration of the horizontal wood trim and backing, as well as wood framing, occurred due to a lack of flashing and caulk. Damage also occurred to the interior drywall due to water leakage from windows. This was demonstrated by water stains on the interior ceiling and walls. Where water intrusion did not occur, siding, structural sheathing, and components were found to be in excellent condition. A number of conclusions were reached as a result of close investigation of this home. These were: first, the 1992 siding replacement was cosmetic in nature and did not address the root causes of the water intrusion. This was evidenced by the recurrence of the same problems within 3 years. Second, where water intrusion did not occur, there was no damage to structural members. Third, all damage to siding, sheathing, structural framing, and wood trim was caused by water intrusion behind the exterior of the building envelope system. Fourth, in walls where no construction-related defects were present, siding and framing performed well. And fifth, where water intrusion occurred, hardboard siding outperformed all other wood components. None of the damage due to water intrusion could be detected before removal of the siding. This was due to improved water resistance of the siding itself. The siding appeared in the best condition of all wood components. Last, and most importantly, all of the problems in the Lockwinds development could have been avoided with the use of simple, basic good construction practices. These practices are common recommendations found in, among others, the Masonite No. 250 application recommendations for the siding product, local and national building codes printed by national and regional building code officials organizations, including the Southern Building Code Congress, Building Officials and Code Association, and the International Code and Building Officials. All codes require the contractor to follow manufacturer's recommendations for the product installed. These sound practices are also found in the American Institute of Architects' Architectural Graphic Standards, viewed as the model for the construction industry. This information is also carried in general construction publications available through general contractor organizations, universities, and libraries. Masonite application instructions were developed from these sources and were written to include and reinforce good construction techniques for the application of its siding products. Jim Quarterman, the inspecting contractor, president of REMS Inc., said of this home, "Poor construction, poor flashing, had basically rotted from the inside out, not the outside in." This is a prime example. The water entered from the roof, went behind the flashing, and rotted the wall from the inside out on both sides. In conclusion, all problems found through the investigation of this home in the Lockwinds development were directly related to water intrusion, which was the result of grossly inferior design and construction techniques coupled with improper installation of the Masonite siding product. Regardless of the exterior cladding system installed on the home, whether aluminum, vinyl, or other exterior cladding systems, the homes would have deteriorated in similar fashion from the inside out due to water intrusion into the wall cavities. Masonite has no responsibility for the water intrusion nor the subsequent related damages that were the result of design and construction deficiencies detailed in this videotape.